Let's take a look at doing an LU factorization essentially from first principles. So imagine we have 1, 2, 3, and then 4 like that. So that's our matrix. What we want to do is write this as a product of a lower triangular matrix and an upper triangular matrix. Why? That's for a separate video. For now, we're just practicing how to do this step. So let's assume, again, that our matrix of 1, 2, 3, 4 can be written in this form. So that means specifically the following, that this is going to be a 1, this is a 0, this is a 1, and this is some entry x that we don't know yet. Right, the upper triangular form will say the following. You're going to have A, B, C, and then here you have a 0. That's what it means to be upper triangular. Let's multiply these out on the right side. So you're going to have the following. Each one is 2 by 2, so the result is also 2 by 2. Let's zoom in a little bit. So you're going to do 1 times A, so 1A, and then 0 times 0, so plus 0 times 0. So you're just doing the dot product of this row 1 0 with this column a 0. So then you're going to do 1 times b plus 0c. So 1b plus 0c. And after that, you're going to do xa plus 1a. So xa plus 1a. 1 0 rather here, which is like 1 times 0, which is 0. Then you're going to do xb and 1c. So the last entry is xb plus 1c. That's the first raw step. Let me clean this up a little bit. So what does this equal? Well, a in the first one, 1b plus 0c is b. Then xa plus 1 times 0 is just xa. And then xb plus 1c is just xb plus c. The only thing you can really do to make sure that two matrices are equal is compare corresponding entries. That's all you can do. So that means over here, the a in red has to be equal to the 1. So you write a equal to 1. That means that, for example, this b here in blue, that has to be equal to the 2 in blue because they're in the same position. So that means b equals 2. That means specifically then this xa in green has to be equal to the 3 right here in green. In other words, you would say xa equals 3, but a we know to be 1. So that means you can say x times 1 equals 3, but x times 1 is just x, so you have x equals positive 3. Now we know the value of x. The last part has to be this one, right? Like this xb plus c, so that's gray. That has to be equal to this 4 in this position right here. So you write that down as an equation. xb plus c has to be equal to 4, but x is 3 and b is 2. We don't know the value of c. This is equal to 4. So c will be equal to 4 minus 6, which is negative 2. So what does this tell us? It tells us the following now, that the matrix 1, 2, 3, 4 is equivalent to the product of those two. So now let's confirm this works. What does that mean? That means 1, and then 0, and then 1, and then for x you put 3. That's a lower triangular matrix. It's got 1s on a diagonal, and then 3 under, and then a 0 above. And then you multiply by the matrix ABC with the 0. So A is 1, B is 2, and then C is negative 2, and then here this is a 0. So that's upper triangular. All the numbers are above the diagonal, just like here all the numbers are below the diagonal. Everywhere else you have a 0. Then we multiply this out to check. So you're going to do 1 times 1. So 1 times 1 plus 0 times 0. Okay, then you're going to do 1 times 2, so 1 times 2. And then you're going to do 0 times negative 2, so plus 0 times negative 2. Then you go on to the next one. You're going to do 3 times 1 plus 1 times 0, so 3 times 1 plus 1 times 0. Then you're going to do 3 times 2, so 3 times 2. And then 1 times negative 2 is negative 2. Then you work through this and see what happens, okay? 1 times 1 plus 0 times 0 is 1. 1 times 2 here plus 0 times negative 2 is 2. Then you're going to do 3 times 1 plus 1 times 0, that's 3. Then you're going to do 3 times 2, which is 6. 6 minus 2 is 4. And this gives back the original matrix. You see how it's worked out? Because we found it that way. I kind of rigged it that way, really, to have the specific effect. So here's all of the work. It's pretty easy to do the LU factorization using this process. You can even do this for a 3 by 3 matrices. You just end up with a lot more equations. See you next video. Give a like if it's been helpful.